We'll go through some of the information related to the coding of this project. So first off, here's the example 1 code that was provided to you with a couple changes. So I did change this capital N that was there to lowercase n, and then a second time right here and a third time right here, because you know the program, when you hit run, it gave some kind of warning about this in red. Actually, the code will run whether you have capital N's or lowercase n's there, but if you don't want that warning to show up, just stick a lowercase n in these 3 locations. Now, any of the lines that have this, well, it's brown colored in this thing, but anything from number sign and then anywhere beyond, like this text right here, this is ignored by the computer, so you can store here any kind of comments you want, anything that you seem stuck on. You can kind of write notes to yourself about this. So if we read through this code, which I did already run once, and that's what you're seeing down here, you see that f is equal to x squared minus ln of x plus 2 times square root of x plus e to the negative x. Now in this, you do need a star right here. So this is not web work, and to get 2 times root x, you do need that times sign. Now the next thing that occurs is that a is set equal to 3 and b is set equal to 20. I mean, I just set up some things here. Finally, I say x value equals a, but earlier the computer knew that a is equal to the value 3, so x value is actually storing the number 3 right now. Total up is another variable that's created, and it stores the number 0 for now, although the value here of that thing will change. And print is just going to show something on screen. So you see how this text here is in double quotes, looking at x value 20 star a, comma, the corresponding output is. And that text right here is literally shown, you know, all the way up to right here, the corresponding output is shown on screen. Then you have something that's not in double quotes. So after a comma, which is used to separate one piece of something printing for another, you see this thingy here. Okay, so first of all, 20 star x value. So x value was set to be 3 currently from over here on line 11. And so what happens is subs means substitute. So we take the formula for f that's over here. The computer is going to substitute for every x. I guess it's going to substitute 60 right now. Okay, so this part right here is really giving you f of 60, and the dot n parentheses thing is just saying, hey, give me this in decimal form, which is what we are going to need because we're adding a bunch of things together. We're approximating anyway. And so having this dot n is going to be real helpful to get a decimal form as opposed to some exact answer. Otherwise, the computer is going to try to store for you, you know, 60 squared minus ln of 60, like in an exact form somehow. So it's just better to get a decimal. And then on screen is printed this line exactly, and you see right here, it's shown on screen. This value is not included in the sum. Then what happens in the code is you see while x value less than or equal to b. So notice there is a colon here right at the end of this while line. And what's going on is the computer is going to check what is the current value of this x value thing, which currently is 3. Is this less or equal to b, which was earlier defined to be 20? Currently, yeah, 3 is less or equal to 20. So the computer is then going to take all these lines that are indented, these lines 1, 2, 3, 4, 5, they're all indented at the same level. That matters. So if you have an extra space there, that's going to break. Well, okay, so 2 of the 5 lines are comments. But what happens is the computer will literally print the text here looking at x value. So, right, the fact that this is here, and then the computer is going to show you what x value is. So that's why this 3 is here. We know x value to be 3. And then you see the text that's literally going to show on screen next is and the corresponding output is, which is shown right there. And then it's actually going to show this value very similar to what we had earlier, except there's no 20 star. I was just kind of playing around to show what you can do. But here, I guess because x value is 3, this is really giving you f of 3 in decimal form. And look, here in this example, f of 3 is equal to 11.4. Then you have this line. Let's take a look. And so what happens is total up was originally set to be 0, but we're now resetting the value of total up. Total up to become what? Well, the old value of total up, which was 0 back here, plus actually this value that we just showed on screen. So after this line runs, total up should be 0 plus, well, this number, 11.4, whatever. So that's the new value of total up. It's 11.4 or whatever, 11.4 something. And then finally, x value is increased from the old x value, which was 3 before, to now be x value plus 1. So in other words, x value is increased by 1. And this comment, I think, is very helpful in describing that. So now the value of x value is now 4 instead of 3. And look, when you do Simpsons rule, you might not want x value to increase by 1 entire unit like this exactly, but you know, this code is not meant to exactly be Simpsons rule. I'm just trying to demonstrate what things you can do. Now that x value is 4, we're in this while loop, and the computer is understanding, look, as long as or while it's true that x value is less than or equal to b, something should happen. So now the computer comes back here and checks again. Is x value less than or equal to b? Well, right now this is now 4. This b is still 20. Yeah, 4 is less than or equal to 20. So these things happen again. So looking at x value 4, that's why this line prints here that says looking at x value 4 that I've highlighted. And this corresponding output is, and you see, 18.6. Well, I guess that's what f of 4 is. And then what happens? Total up equals, total up, the old value of 11.4 or whatever, plus this f subs, that's this value that was shown. So this 18.6 is added to the previous total up value, which was 11. And so, you get a number that's, I guess, what, approximately 29 point something, maybe 30 point something, right? And then x value is increased again. So, x value is reassigned the value. Instead of now, it used to be 4, but 4 plus 1. So now x value is 5. And then the computer tests again. 5 less than or equal to 20 says yes, and that's why this next line shows, and the next line shows. And so all you're seeing on screen here is 3 and f of 3, 4 and f of 4, 5 and f of 5 in a decimal form, and so on and so on. And then eventually, x value is 19, so then you do 19 plus 1, x value is 20, and the computer checks, is 20 less than or equal to 20? Sure is. So the computer runs all this stuff again. That's why you see this line that says looking at x value 20, and the corresponding output is 405. But then take a look. Then x value is now assigned the value 21. And so the computer comes back here and checks, is x value less than or equal to b? Or is 21 less than or equal to 20? And the computer finally says, no, that's true. So then now skips all these indented lines and instead comes here and then says the sum of all the outputs is, and shows the current value of total up, which, by the way, total up started at 0, and we kept adding to total up's value itself plus a new value, f of something. So this 2,941, this really should be the computer's calculation of 11 plus 18 plus 27 plus 39. That is this 2,941. Okay. The purpose of this first example, it's smaller than the second example, and this is just meant to show really, how you have a function and how you find f of something. Here we're finding f of 60, and here within the loop setting we're finding f of 3 and f of 4 and f of 5. And this total up idea, starting total up at 0, is trying to show how you can really take f of this and f of that and f of something else and add these values up. Right? Now the second piece of code is a bit more complicated, but not too crazy. I have not modified this code yet here, but where this capital N is, it will be helpful to make that a lowercase n. And the other thing is, I did neglect, in this code, there is no function f that's defined, and that's because I ran one code after the other, so I didn't notice an error. But if I just copy from our example 1, let me go back to example 2, just paste this in somewhere before the while loop, and then let me run this code so the computer can think as we run through. So here a is set equal to 10, b is set equal to 20. There's a couple other things that are defined. I called this thing dx, you could call it delta x. Again, some function is defined here, and now I have x value less than b, as opposed to less than or equal to b. Just to point out that, you can do a less than b if you like. You've got to decide what you need to do for your code. I'd like to skip past these lines for a moment and just go to this print line. So now, what should happen is there's this line that says c mult star x f of x value is. And that's this line right here. So I'm skipping past this first line. That comes from somewhere up earlier. But now what's shown on screen is, I guess, f of x value. Turn that into the decimal form. That's what that dot n is again. But then times mult. And we did not talk about mult, but that is somewhere up here, and we'll talk about that later. Then it's showing mult is, and it's showing what the value of mult is right there. So this highlighted mult is turning into 1, 2, 3, 4, 5 for some reason, and this comma mult is actually just showing that text right there. And it's also, this is showing you the value of x value right on screen as well. And then this time x value is increased, but not by 1, but by dx or delta x. And then I show on screen this information. We are now increasing I from blah to blah. And so you see here as well, this I is not in double quotes. That's why you're seeing the value, and then I plus 1. But this print line is not really doing anything. That's just showing information on screen. What's really increasing I is this next line. I is equal to I plus 1. So we've got x value. When we talk about like f of x sub I, this is x sub I. And then this is just the sub I. This is the I part, right? Which interval we're in. I printed a bunch of dashes to the screen to try to separate information. Makes it a little easier to see what's going on, right? And then this loop runs again and again and again and again and so on, right? So What is going on with the molt? And we've got to look here for that. So now, how is molt being determined? Now, this is really, some number multiplied by f of something, I guess f of 10 in our example to start with. And so what's going on is, right away in the loop, I'd like to set the value of molt appropriately. And what I did was I started I at 1. You've got to decide whether that's something you need to do. But here I have I equals 1, meaning I is getting assigned the value 1. Here, I equals 1 is a little different. This is asking making the computer ask, hey, whatever the current value of I is that actually equal to 1? And if yes, then the computer will run this indented stuff. It will print something on screen, and then that's why we're seeing this text right here. When I is equal to 1, this text will print on screen, and then the variable molt is getting set equal to 1, 2, 3, 4, 5, which may or may not be useful for Simpsons rule. Not this number exactly, but I'm just trying to demonstrate a point. So if I is not equal to 1, otherwise, then do something else. So this elif is a short hand for else if. So else if, or in other words, if I is not equal to 1, then check, is I equal to n? And if I was already equal to 1, then this part happens, and then all this part is skipped here, right? But if I is not equal to 1, then the computer is going to check is I equal to n. And if, in fact, I is equal to n, then this part's going to run. Now, otherwise, there's a catch-all here, else. So if I is not equal to 1, and I is not equal to n, then the part indented here is going to run. So then, this text is actually really useful to have printed on screen. I is some number other than the first or the last. And in fact, it's going to show you what value I is, like right here with this namely 2, right? I highlighted this 2. Now what's going to happen is I%2. That's going to be the remainder of I when you divide by 2. And if I is odd, the remainder when dividing by 2 is 1. So this is checking, is the remainder when divided by 2 equal to 1? So test if that's true. That's what the double equals is about. And this printed information is, again, being very honest. It's not deceptive. This is really what this is trying to get at. So here, if we're indented and we're running this part, it's because I happens to be an odd number. Otherwise, the remainder of I divided by 2 happens to be something else. Well, it's going to be 0. And so this highlighted stuff is going to run whenever I is even, right? So if I is 1, this happens. And if I is n, this part is going to happen. And otherwise, if I is some number between 1 and n, I suppose, then this part happens. And which thing happens? Well, if I is odd, this part's going to happen. And if I is even, this is going to happen. And look, in each case, you're just setting the value of this variable called molt. And that's in front here. So that sort of ought to act like a coefficient somehow. When you're running this in the beginning, it's useful to show a lot of information on screen. If something does not seem to make sense, you ought to really just show more and more information. Increase the number of print lines. Just show even more information, right? If you're ever unsure about something, like you could even just, like for instance right here, if you're not sure about this molt thing, maybe I just copy pasted this line and you have a line where you don't show the molt part, right? So I just want to know what is f of x value, right? And this is equal to, and then you can run things like this. And now additional, this, I just want to know, this is just showing you more information on screen. And then, well, this times 246, I guess that's, the computer's telling you that's 36,000 whatever, right? So you can get a lot of information on screen. It's just later on, when you look at Simpsons rule, because you are approximating a definite integral, of a function f from 0 to 200, then n is going to be something big. I don't know really how big right off the top of my head, but maybe it's 1,000 or something. And you don't want 1,000 things that look like this to show on screen. So when you're ready, like you use a lot of print lines in the beginning, but once you're sure your code is doing the right thing, and in fact what you can do is, look at the 2 textbook examples of Simpsons rule. There are 2 examples done when n is equal to 10. But once you're sure that everything is doing what you want it to do, then get rid of all of the print lines, especially the ones that are in the loop, right, in this indented while section, because it's a lot of information. And then even with n being really large, like 1,000, then everything runs here, right? So same thing back in example 1, maybe like this is different because there's no n here, but how do you make this thing run a lot? Like you would change b, sorry, let's not do that. We started with b is 20. Let me just make b is 200. And right there already, look, I scroll down, that's a lot of information. But if you want, to keep doing this, you could do something like that, but I'm not going to run this yet because it's going to produce 20,000 lines of information. I don't need all that. So maybe in this case, I comment this line out and I just run this. And so not, and then the only thing that's going to show is this total up, and actually the computer's still working on the value. So maybe, there it is. Yeah. So now the computer gave, 2.6 times 10 to the 12th power or whatever, right? So look, the computer will what am I trying to say here? Show these print lines sort of like this if you need to, but be sure when you're doing so that maybe in this first code, B should be fairly modest, right? In the second code, N would have to be not too big, right? Otherwise, you don't want to show too much information on screen. Both of these codes are meant to show sort of different sorts of things. The first code is really, again, meant to show how do you, add up a bunch of things. Well, you create a variable that starts at a value of 0, and you keep adding things to itself. But in Simpsons rule, you're not just adding f of 3 and f of 4 and f of 5. You're adding something times that, and that's why I've asked, these sort of, let me make sure that n is small again here, like 10. That's why there are lines, like this mult times f dot subs here, right? This is trying to get across the idea that you've got the value of a function, but you've got to multiply by a certain number. So those numbers, maybe they're 1, 3, 5, 2, 4, 6, maybe not. Maybe instead of numbers like 1, 2, 3, 4, 5, I believe Simpsons rule has lots of 1s and 2s and 4s instead, right? So that's the idea that you need to kind of work out. So the codes are trying to show some of the things that you can do. Be sure to take, go to desmos.com, and in Desmos, if you